Frequency, abbreviated as F, is defined as the number of revolutions an object makes per second. Frequency is also equal to 1 over the period. T stands for period. And of course, period would be 1 over the frequency. A rotating object moves through an angular displacement of theta equals 2 pi r radians in 1 revolution, and the time it takes to go 1 revolution is a period. So if I want to find the linear velocity of any point on a rotating object, or the tangential velocity as we've been naming it, the velocity will be your arc length covered divided by time. So if you make a complete circle, what distance have you covered? Well, you've covered 2 pi r, and what time did it take you to do that in? A period. So this equation right here, velocity is 2 pi r over t, is very important. And then what's t equal to? 1 over f. So the velocity is equal to 2 pi r f. This is the linear velocity or the tangential velocity of an object on a rotating disk. This is very useful for solving rotational motion problems. Now, with all this algebra up here, try putting that together and come up with the relationship between angular velocity, which is omega, and frequency, which is f. This repeats what we did on the previous slide, but let's show it again. Velocity is displacement over time. When you're going around a circle, this displacement here is also called the arc length that you travel. And if you make 1 full rotation, you cover a distance of 2 pi r, the circumference of the circle. The time it takes you to do that is 1 period. So we have the velocity is 2 pi r times 1 over the period, and 1 over the period is frequency. So we have velocity is 2 pi r f. So let's start with this now. Divide both sides of this equation by 2 pi r, and you get frequency is velocity over 2 pi r. Now, what's velocity equal to? Well, rotational motion, it's equal to r omega, so I make that substitution. Now you can see we have an r in both cases, they cancel. So the frequency is omega over 2 pi. One more step, and omega is equal to 2 pi times the frequency. So the angular velocity of a rotating object is equal to 2 times its frequency of rotation.